Okay, good morning everyone. Today we're going to start section 4.6 and we're going to review the fundamental theorem of algebra, which is so easy. So as long as you're listening, you'll be able to understand this. When you're trying to find the roots or the zeros of your polynomial, you look at your polynomial. What degree is this polynomial? 3. That means it has 3 roots. You have to find 3 roots. It has 3 answers. Very, very simple. Okay, with that being said, you need to use your graphing calculator for this because this is how you're going to make your life so much easier and you're going to check your answers. So I've already plugged it in here. Now I'm going to press graph. Now, instead of using the rational root theorem here that we learned to guess my roots, I'm going to graph it and I'm going to find my roots. So once you have plugged it into your calculator, go ahead and click graph. And as it comes up, you can look at it and you can see, okay, I think I know where the roots are. According to my graph, it looks like the roots are at -2 and -3. Okay, so I'm going to zoom in here. Okay, so that's -2. So I'm going to check it. Here's how you check it. You press second, trace, 0, and you're going to look at my x. My x is at 0. I don't see my cursor because 0 is up here. I'm going to move to the left till I see my cursor. And you can look at your x. There it is. And I'm going to put it where I think the 0 is. So I think that's where the 0 is. I'm going to press left once, because right here it says left bound, and I'm going to press enter. Now it says right bound. I'm going to move, that's where I think it is. I'm going to move it once to the right. I'm going to press enter. And then I'm going to go back to where I think it is. You see the word guess, and I press guess, and it calculates at 1.999. I'm going to round that to 2. So in other words, instead of doing the rational root theorem, I just found my root. So let's finish the problem using synthetic division. 1, 7, 16, 12. I already know that -2 is a 0. That means that this answer here should be 0. Drop it, multiply, add. Multiply, add. Multiply, add. Look at that, it becomes 0. Perfect. So that means that there's a 0 at -2. Now, if I were to write this, x squared plus 5x plus 6. Let me see if I can factor it from here. 6. Can I make 5 with positive 6? Yes, I can. How do I factor this one? 2 and 3. So x plus 2 and x plus 3. Now, that means, what are the roots from here? -2. So don't forget about this first root. The roots are -2, -2, and positive 3. How many roots is that? 3. What was the degree of the polynomial? 3. So there are your answers. Now there's a special way to write this double. So see how there are the doubles, and you know when you graph it, it bounces off. And if you look at your graph, where is it? You can see that it actually does bounce off of -2. Here's how you write it. You're going to write -2 m2, comma 3. This notation means -2 is a multiplicity twice. So sometimes you're going to get roots that show up 3 times. So if it showed up 3 times, you would write -2 m for multiplicity 3. Oh, I'm sorry, -3. Thank you for catching my mistake. Okay, so I'm moving on to monitoring progress number 4. Take a look at this beautiful polynomial. What degree is it? 5th, which means how many roots are we looking for? 5. All right. Now, I cannot group this. It's a high degree polynomial, so we're going to plug it into my calculator. And we're going to check the roots. So I'm going to press graph. It's thinking. Okay. So, it looks like there's a root at positive 1. Actually, how many roots are there at positive 1? At least 2, right? So, there also looks like there might be one at negative 1. So let's do second trace 0, just to double check. So I'm going to press second trace 0. I look right now, my cursor's at negative 2, which is going to be all the way down here. So that means I have to move it to the right until I get close to negative 1. Now, look at this. It doesn't want to sit on the line where I think the root is, but I'm going to get as close as possible to it. So I think that it's here. That's the closest spot, and you only go left and right. This is the closest spot. So I go left for left bound, enter. I think that's where it was. I'm going to go up 1 for right bound, enter. I'm going to go back down to where I think it is, and then I'm going to press guess. And where does it tell me my 0 is? Negative 1, yes. So, here we go. Make sure when you're writing down your coefficients that you're not missing an exponent. 5, 4, 3, 2, 1. Okay, we're good. Drop, multiply, add, multiply, add, multiply, add, multiply, add. Oh, I made a mistake. Let's go back. I subtracted here. 9. Let's try it again. Thank you. Five plus 4, 9. Multiply, negative 9. Add, negative 10. Multiply, positive 10. Add, positive 4. Multiply, negative 4. And I got a 0. So you can see from the mistake that I made, which was really just a stupid arithmetic mistake that I wasn't focusing on it, that I got down here to the end and I realized I didn't have a 0. So I'm like, oh my gosh, I made a mistake. So let's go back and find out where my mistake was. Okay, now looking at this polynomial, I already know that I can't factor it. I already know that. So what we're going to do, we're going to do it all over again, synthetic division. What this would look like would be x to the 4th minus 4x cubed plus 9x squared minus 10x plus 4. And if you forget what degree you're in, because maybe you're on a different piece of paper or you just don't remember, you always start here at the end. This is always going to be the constant, so that's x to the 0, x to the 1st, 2nd, 3rd, and 4th. Okay, again, I'm going to use my calculator. Let me plug it in. So now I'm going to plug in my new equation, and we're going to start over. So you're just digging deeper and deeper into the same problem. X to the 4th. Okay, now that I have it in my graphing calculator, let's graph it. Wait a minute for it to come up. Okay, where does it say that there is a possible 2 roots? At positive 1. But let's double check. So, second trace 0. Right now, my cursor's at negative 2. I can see it right here. So I'm going to move it to the right to move it to positive 1. There it is. Okay, that's where I think it is. So I'm going to go 1 to the left, left bound, enter. 1 to the right, enter. Go to where I think it is, guess. And it's a 0.9999, which I'm going to round out to positive 1. So let's use positive 1. Okay. 1, negative 4, 9, negative 10, and 4. Okay, let me work slowly so I'm not making some stupid arithmetic mistakes. Drop it, multiply, add. Multiply, add. Multiply, add. Multiply, Yay, that comes out to be 0. Now, I can rewrite this again if you want to. You don't have to. Okay, now 4, yay, I can group it. Let me see if I can before I do synthetic division. If you want to just continue with synthetic division, totally fine. But maybe I can group this. If I take out an x squared, this will be minus 3. Oh no, I can't group it. Because if I take out a 2, this is going to be minus 2. Let me show you, and I'll just rewrite it. If I take out an x squared, plus, and then I take out a 2, these two terms need to be the same. So I cannot factor this using grouping. So again, I'm going to use synthetic division. Here we go. I'm going to plug it in again in my calculator. Alright, here's the next equation that we couldn't group. Back in my graphing calculator, I'm going to press graph. And it shows me that there's possible root at what number? 1. So I'm going to do it again so that you get lots of practice with this. I'm going to press second, trace 0. Right now I'm at negative 2. I'm going to move it over. And I think it's at 1. So I'm going to go 1 to the left, enter. 2 to the right, enter. 1 to the left, enter. My 0 is at 1. Perfect. Okay, synthetic division again. Drop it, multiply, add, multiply, add, multiply. There's my 0. So this is now x squared minus 2x plus 4. Okay, so far, how many roots have we found? 3. We need how many more? 2. Because there's a total of 5. We have 3 roots so far. We need 2 more. Can I factor this? Not normal factoring. So guess what we're going to use? Quadratic formula. Alright. I'm going to squeeze it here on the side so you guys can see it. Quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. X equals 2 plus or minus radical 4 minus 16 is negative 12 all over 2. Oh, there's a negative 12 here inside the radical. I'm going to do it up here on the side. You know that negative 12, just break it up, is negative 1 times 12. What is radical negative 1? I. Okay. Rad 12 is really 4 times 3. I'm going to take out the 4 because it's a perfect square. So it's going to be 2 rad 3. Okay, so I'm going to rewrite that so it makes sense. It's going to be plus and minus 2I rad 3. Okay, I'm going to squeeze it in here. X equals 2 plus or minus 2I rad 3 all over 2. Does anyone notice anything that you can do with this fraction? We can reduce it. So all of these whole numbers here, we can reduce them. What can I reduce them by? 2, right? So I'm going to move it over here. So x equals 1 plus or minus I rad 3. Huh. Perfect. Okay. How many roots is this right here? 2. It's 1 plus I rad 3, 1 minus I rad 3. Here's my third root. 4th root and 5th root. So how would I write that as an answer? I would go, let's do it up here. Negative 1, 1, M2, and then 1 plus or minus I rad 3.